One of the tools that we can use is this idea called the addition property of equality. So to help you get a sense of what that means, let's imagine that we have an equation that says maybe x equals an 11. It's a linear equation, x equals 11. Let's say I have another one that says x minus 3 equals 8. Now, if you were to look at those, you can look and say, well, you know what x makes the top one true? Well, 11. 11 equals 11. And the second one, x could also equal 11. 11 minus 3 equals 8. So what we can say then is that 11 minus 3 equals 8. You're going, yeah, Willie, okay. That I know. So what does this have to do with this addition property of equality? Well, what we can imagine is just, let's say that we have something that x minus 3 and I want to figure out what x by itself would be. Well, what would you want to add maybe to the sign so x gets by itself? You would probably add something like a 3. And because this has an equality sign, one of the rules that we're going to discover, and I hope it makes intuitive sense, is that I need to add 3 to the other side as well. And if I did that, you would see that would get x equals 11, which is what we've already discovered. But in this process, we've kind of used this idea about the addition property of equality, which says that if I have some a equaling to b, then I know that if I add some number to c, it will still equal the b plus that some number. It's called the additive or the addition property equality, which says that if I add one thing to one side, I have to add it to the other side of the equation. And I kind of think of it like scales. I want to maintain the balance, and that's what equal means. It's a balance. So if I add something to this side, I have to add the same amount to the other side to maintain its balance. Or I'd hate to push up weights that are off balance. So that's what the additive property of equality says is, can you think of a number to add to both sides so that the x gets by itself? So let's look at an example of how this plays out. So let's build off this example and kind of demonstrate a little bit more of a formal way and a formal pattern that will help us continue to solve these and solve some of them more that might be a little bit more complex as we continue along. So I want to solve x minus 3 equals 8. Yes, of course, I can go through and think of numbers that make this true. But the pattern that we want you to develop is I want to think of a number that can add to both sides such that x gets by itself. Or we would say we isolate the variable x. So I'm going to say x minus 3 plus 3, because doing that's going to isolate the value of x, equals 8. And again, in order to maintain the balance, I better add it to the other side. That is what's key here. Whatever you do to one side of the equation, you have to do to the other side. So x minus 3 plus a 3, that's an x plus a 0. On the right side, 8 plus 3 equals 11. And then x plus 0 is just an x. X equals 11. So there's my solution for this first linear equation, x equals 11. And it's a good idea to always check. So let's take our value that we got for 11, or for x, which is 11, substitute it into the equation. So 11 minus 3 equals 8. Is that true? 11 minus 3 is 8. 8 equals 8. And so that tells me I have a true statement, which tells me my value that I found for x is the correct and only value that makes this linear equation true.